Hi, I'm Tom from Heroic Labs, and today I'll be joined by Sean, who heads up our developer relations team here at Heroic. And in this video, we'll be showing you how to set up a bucketed leaderboard system using Nakama server runtime code. Before we get started, why don't you quickly introduce yourself, Sean?
Hi, I'm Sean. Our DevRel team produces the various documentation, sample games, tutorials, and guides that help developers learn and master Nakama. Back to you, Tom.
Great. So Sean, can you tell us what a bucketed leaderboard system is and why it's a useful feature to implement?
Sure, Tom. As player bases in social games grow, the global leaderboards become static, with little movement at any particular skill or score level, resulting in a reduced interest to compete and continue playing the game. This is where bucketed leaderboards can help. In bucketed leaderboards, players don't play against everyone, but instead see a limited view, often just 25 to 50 players. They compete against the group until the leaderboard expires or rolls over. These smaller groups of players are known as cohorts or player buckets, which is where the bucketed leaderboards name originates. Bucketed leaderboards can be seen in many popular games, including several titles in Rovio's Angry Birds franchise. We are going to show you how you can use Nakama's server framework and the storage engine and leaderboard features to build a simple and scalable bucketed leaderboard system for your game.
Thanks, Sean. Before we dive into the code, let's briefly cover how we'll implement a bucketed leaderboard system using Nakama server runtime code, utilizing the built-in leaderboards and storage engine features. First, we'll create a single global leaderboard that all players will submit their scores to, and this leaderboard will have an expiry time. With the global leaderboard in place, we need a way to create a personalized view or bucket of that leaderboard for each user. To do this, we'll use the storage engine to save an object for each user that contains a generated list of user IDs that will serve as a cohort of players that makes up the bucketed leaderboard for that user. This object will also store the expiry timestamp of the global leaderboard so that we can regenerate the bucket as and when required. Next, we'll use Nakama server runtime code to expose an RPC, which will either retrieve or create this bucketed leaderboard storage object, and then grab all of the leaderboard records from the global leaderboard for each user ID in the bucket, and then return that result to the user as a custom view on top of the existing global leaderboard. Creating a view over a global leaderboard in this way is an efficient way to provide each player with a leaderboard that is unique to them without having the overheads of creating individual leaderboards for each player. Using this method, you can provide users with leaderboards that are tailored for them, for example, by just including their friends or guildmates, or perhaps just including players around their skill level, all while only maintaining a single global leaderboard. Let's open up our server project using VS Code and jump into the main.go file. This serves as our server runtime code bootstrapper, and it's where we'll register our RPCs. The first thing we do when the server starts is create a global leaderboard, which we'll later create our bucketed leaderboard view from. To do this, we create a variable to hold the leaderboard's ID, and then we call the createLeaderboard function. Inside this function, you can see that we call the nk.leaderboardCreate function, passing it our context, the leaderboard ID, and a few other parameters to determine the scoring method and leaderboard reset time, which is defined in a standard cron format. I'll leave a link in the description to the full documentation that details how each of these parameters work. If there's an error, we log it to the server console and return. Otherwise, we log out that the leaderboard was created successfully. Now that we've created our leaderboard, we can register our RPCs. You'll see here that we're registering two. The first retrieves or creates a bucketed leaderboard for the user. If one already exists and hasn't expired, the RPC will fetch it. Otherwise, it will create a new one and return that. The second RPC will always generate a brand new bucketed leaderboard for the user. This is useful if you want to provide a way to re-roll the user's leaderboard, and we'll demonstrate this in the demo project a little later. For both of these RPCs, you can see that we call a function called RPC getBucketRecordsFN. We pass in the ID of the leaderboard, the size of the bucket we'd like to create, and whether or not it should always force create a new bucket. This function then returns another function, which the RPC will call when executed. Let's dive into this function now by heading into the bucketedleaderboards.go file. We start by defining our package, importing relevant modules, and then defining some error variables which we'll use throughout. Next, we define a struct to store our bucket storage object. This will be used to store a list of user IDs that will represent our bucketed leaderboard, along with a timestamp indicating when this bucketed leaderboard should expire. With our struct defined, let's look at the RPC function. You can see here that unlike a typical RPC function declaration, we're actually defining a higher order function, which returns a function that acts as the RPC handler. This allows us to register multiple RPCs with slightly different parameters. For For example, we can use the same function to register RPCs that create buckets of different sizes, or for different global leaderboards, or that always generate a new bucket. The first thing we do is some validation to ensure that we didn't receive a payload and that we have a valid user ID in our context. After that, we define the collection and key we want to read from, and then attempt to read from the storage engine to grab any existing bucketed leaderboard for the user. We then create an empty bucket storage object and populate it with the existing bucket storage object if it existed. Next, we get the global leaderboard object and check to see if either the bucket has expired, or there are no users in the bucket, or if the force regenerate option has been specified. If any of these are true, we regenerate the bucketed leaderboard by calling the add users to bucket function. We pass in the bucket storage object, the current user's ID, the bucket size to generate, and a Boolean value indicating whether or not to use a pivot when selecting users from the global leaderboard, as well as a context, logger, and database object. Let's have a look at the add users to bucket function. We first define a couple of variables to store the rows and any potential error. Then we check if the usePivot parameter is true. If it is, we generate a new UUID and use it inside a select query to select a random selection of users from the table. If the value is false, we simply select however many users we need from the top of the table.
Tom, could you explain what you mean when you say pivot and why we use it?
Yeah, certainly. In this case, I'm using the term pivot to define a random point in the database's user table, from which we will sample user ID records. Since the user table has an index on the user ID field, which happens to be a UUID, we can generate a random UUID and use a SQL where clause to begin sampling users from this point in the table. It's a simple and highly performant way of selecting a random set of users from the database.
Thanks, Tom.
No problem. Looking back at the code, we then loop through the rows and filter out where the ID is the system user or the current user. If you wanted to perform additional filtering, like only users with a particular stat threshold, you do that here also. It's faster and more efficient to overscan in the select query and filter it in memory than in the SQL query. This is because the user table has an index on the ID column, as well as a few others, but not on every possible field. If the row is not filtered, we add it to the user IDs array on the bucket storage object. Going back to our RPC function, you can see that we first add users by using the pivot to select a random sample, and then, if we do not have enough users to fill the bucket, we add users from the beginning of the table. We then set the bucket expiry time to be same as the next reset time for the leaderboard in question. Once done, we convert the bucket object to JSON and write it back to the storage engine. The final part of this function is responsible for building the payload that we send back to the user. Here, we add the current user's ID to the list so that they see themselves as part of the bucketed leaderboard. We then retrieve the list of leaderboard records from the global leaderboard for each user in the bucket. And finally, we add the records into a leaderboard record list object and convert that into a JSON string which we pass back to the user.
Great. So with that, are we ready to test it out?
We are. Let's launch our server with Docker and open up a sample Unity project I created. You can see now that if I run this project and log in, I'm presented with a leaderboard. What I'm seeing here is my own bucketed leaderboard, or a subset of the global leaderboard that's unique to me. If I were to log out and log back in, I would see the exact same view of the leaderboard until the global leaderboard itself resets. Or I can click this button here to force regenerate a new bucketed leaderboard. This will fetch a brand new subset of users and add them into my own unique bucketed leaderboard.
Can you show us how that looks in the Nakama console?
Of course. Let's dive into the console and head over to the storage section. You can see here that we have a record in the buckets collection with a key of bucket for our user. If I click into it, you can see that it has an array of user IDs as well as a reset timestamp. This is the bucket storage object we generated in our server runtime code, and this is what is being used to create a bucketed view of the global leaderboard that's unique to my user ID.
Nice one, Tom. So you can see, bucket leaderboards are a fantastic way to increase player engagement by allowing players to compete on a smaller, more dynamic leaderboard versus against the entire player base. This will give your players a stronger sense of progression as they see their rank rise and fall. And it gives you the tools to create even more specialized leaderboards. For example, a friends or guild-only leaderboard.
As always, all of the links to the relevant documentation can be found in the description below. Thank you so much for watching, and we'll see you in the next one.